Hello folks, we come to the part 3 video of this exercise. We should say that this is an important part because both the problems are slightly high end. So let's see now how to get across doing this problem. The first problem, they say that the coin is tossed 4 times, and then you have to, they say that when you toss it 4 times, whenever there is an amount associated with it, that every time that you get a head you get 1 rupee, but every time you get a tail you lose 1.5. Like that, for every outcome there is an amount associated. So you have to find out the amount that is associated with each such throw, and you have to make a sample space of this amount. That's the first thing to do. Second thing to do is, suppose we were to get this amount, then what is the probability that is associated? That way the question goes. So let's work it out and let's see how it comes. First of all, let's write the sample space of the experiment. That is, when we toss 4 coins, what all outcomes can come. So let S be the sample space. That we will have to specify because the sample space has to be written once more. So let S be the sample space of outcomes during 4 throws, during tossing of coins 4 times, right? So all heads, 1 head, two heads, three heads, and no head. So no head means that's it. So this is our required sample space. Now we'll have to find out the money associated. So let's take for no head. Yeah, no head means the outcome is right. So required amount minus, right? Tail means minus. So 1.5 into 4, or minus 1.5, minus 1.5, minus 1.5, minus 1.5. It will come to minus rupees 6, right? I think why not we tabulate this, right? So that our work, every time we don't write, say when we write things repeatedly, that's a time when we make a table, so that we don't cases, outcome and amount. Yeah, so first we said no head, so we had TTT and we got it as 1.4 minus 6. Now 1 head means like this. So what is the amount associated with it? See, we also have to find the probability. So if we are very careful not to make one more column later on, we can write the probability also, right? So that we can do it later, but let's right now check the amount. Now here the amount is 1 head, so it will give you plus 1, but there are 3 tails, so it is minus 1 into 3. So it's like 1 minus 4.5, that is minus 3.5. Okay, then 2 heads, 2 heads HHTT TTHH, then HTTH, THHT, then HTHT, TH. Right? Now in both the cases, plus 1 into 2 and minus 1.5 into 3. So that means 2 minus, 2, this is also 2. So 1.5 into 2 is 3. So it's minus 1. Right? Then we can have 3 heads. HHHT, THHH, HTHH, and HHTH. Right? Now what is the amount associated over here? It is 1 into 3 minus 1.5 into 1. So 3 minus 1.5, 1.5. It's plus 1.5. Now 4 heads. 4 heads means HHHH. So how much will come? 4 heads. That means it is 4 into 1, 4 rupees. Right? So the sample space for these amounts are minus 6, minus 3.5, minus 1 and 4. So the required sample space of the amounts. Required sample space of the amounts is positive 1.5 rupees, 1.5 rupees 4, minus rupees 3.5 and minus rupees 1. Oh, minus rupees 6 also, negative. So that is the sample space. Now they have asked us that for each of these things you should find out the probability. Now that's easy, right? Sample space, we have got 16 elements. If you want, you can observe. So we have to just check. This is only 1 out of 16, right? Here it is 4 out of 16, which is 1 by 4. Here it is 6 out of 16, which is 2 3s are 2 8s are 3 out of 8. Here also 4 out of 16. Here it is 1 out of 16. That's it. This is the scope of the question. This is what they ask us. So that's about the problem number 7. Then we can quickly jump to problem number 8. This is a higher end problem, and there are problems of this type in the probability chapter in our 12th standard also. So if you say, basically there are many things in that, even in the 3D chapter and even in the chapter on 3-dimensional geometry and conic sections and straight lines. Those 3 chapters, there are many things which are coming in the 12th standard. So also here. So these are things which are coming in when derivatives. I was telling that these are things coming back again in the 12th standard. So these are things, they come back there. So if this would have got inside your head, you are able to do that work faster. That's how it is. So that's about this. Then we are moving quickly to the problem number 8. It says that 3 coins are tossed. There it was 4 coins, now we are tossing 3 coins. And then you have to write all that. So let's start directly because there's nothing new, we have done it, right? So let's start. Let S be the sample space. And let's list it. All 3 heads, 1 head. Two heads. Then no one. Right. Now number of elements 8. We have to find out the probability of getting 3 heads. Right. So let first thing, let A be the event, required event. Why? Because we are working with subparts, required event. So getting 3 heads means it is HHH. So N of A is 1, P of A is N of A by N of S, which is 1 out of 8. Right. second subpart. What do they ask us? Getting two heads, right? So let B be the required event. Two heads means exactly two heads. So how many are there? 3. Probability that's about that. Okay, so we come to the third one. At least two heads, at least and at most will get a lot of work done from you, because at least 2 means you have to consider the 2 also and the 3 also, right? So let C be the required event. And what all elements will be there? At least 2 heads, so 2 heads and 3 heads, right? So how many are there? It is 4. So like that, what will be the probability? Half. Come to the fourth part. There are 9 parts. I don't know how I'm going to manage the space. Okay, the fourth part says that there's at most 2 heads. So let D be the required event. Let's see if this is going to help us. D says that you should have at most 2 heads, maximum 2 heads. That means you can have no head, you can have 1 head, and you can have 2 heads. So no head, 1 head, and 2 heads. So how many items do we have? We are having 7. Like that, our probability comes to, yes. Now the fifth one, no head. Okay, let E be the required event. No head means it's only tail, right? Yes. Suppose there are 3 tails. So let F be the required event. In which all cases do we have 3 tails? Only in one case, right? So our probability is also 1. So sorry, our number is 1. So that is also 1 out of 8. Then we have getting exactly 2 tails. They ask us exactly 2 tails. So let exactly what is that? Exactly 2 tails, right? 2 tails. So n of g is 3, like that. Come to the 8th subpart, which says that no tail. Yeah, you have to find out a case when there is no tail. So let H, I hope we don't get confused with the H there. I think we can skip H. Why? Sometimes with the H and T we'll get confused. So A, B, C, D, F, G, H, I will get. Let's take it. Let I be the required event. Right? So what happens to I? There is no tail. That can happen only over here. So number of elements here is just 1. So what's the probability? 1 out of 8. Then at most 2 tails, maximum 2 tails. That means you can have no tail, you can have 1 tail, and you can have 2 tails. So let J be the required event, right? So J, no tail, 1 tail and 2 tail. So no tail, then 1 tail, and 2 tails. Right. So this is 7. That's about this. So this is how we have worked up with this exercise with so many things. So 2 more problems that we'll take up in the next video. It was voluminous. I've done a lot of writing. You can be good. You can take your copywriting, this as a copywriting class. So much of writing. Thank you. We meet in the next video.